Hello, in this video I'm going to explain a new concept called operation effectiveness, which is essentially a new way to calculate shop floor efficiencies at the operation level. So if you have any manufacturing background, you know that the way to go today to calculate equipment, machines, work center station efficiency is called OEE, or overall equipment effectiveness, which is by the book, the formula below here: availability times performance times quality. So just for those that is not very familiar with this concept, essentially you have a lead time of 60 hours in the example, and you're losing 10 hours due to availability loss, 15 hours due to performance loss, 10 hours due to quality loss. And from those 60 hours, only 25 hours are actually adding value to your product. So this is the overall concept of OEE. So explaining this a little bit better will help you understand operation effectiveness. So looking at this example, we have a machine called CNC1, which stop works from 7:30 and stop work is at 11:30, and then resumes working 7:30 the next day. So we have scheduled one operation that is has a planned process time of 10 hours, and it's should produce 100 items. So this is the plan. But when this operation actually is executed, so the actual state of this operation after it's completed is it took 8 hours of process time, so it's doing better than the plan. But then it took 2 hours of rework time, 4 hours of unavailable time. So it had to enter off shift here of 8 hours. So my total production time from beginning to end, it is 22 hours. So with those informations, you can, with the planned information and with the actual information, you can calculate the OEE. I'm not going to go through the details of this because also every manufacturing unit can change the formulas a little bit. But you calculate the availability, which is 71, the performances, which is 125, quality, which is 80, and you multiply those to get the 71%. So this example is for a single operation, but an actual OEE calculation is taking account every operation running at a given work center. And it's not just something that you calculate and you do nothing with the number. OEEs can be used for a better quotation and scheduling and planning activities. So using that same previous example, planned, you should take 10 hours, but if you apply a 71% efficiency, if you pick up 10 hours divided by 0.71 and add those 8 hours of off shift, you're also going to get the 22 hours lead time. So that's how OEE is actually helpful for your planning and quotation activities. Multiple ways to calculate OEE. No right or wrong here. By the book, there is a standard way, but every manufacturing unit might tailor the formulas a little bit in order for it to better represent their own reality. But the important thing is that to use OEE for something, right? Uh, it's also very common to assign goals to the OEE. So, for example, efficiency of 71. Let's say that's the actual OEE calculated for the whole, all operations running through that work center. Then you might have a decision to apply an OEE of 75%. So you have kind of a goal and you challenge the shop floor to do better, right? So what are the issues with OEE? So the first thing here is understanding that it's an old concept. So it was invented in the 60s by a Japanese pioneer and creator of the total productive maintenance. It's not because it's old that it's bad, but there are better technology methods today to improve this, right? It's also on an average. So if it takes in account every data point without specializing per production parameters. So you could, of course, remove outliers from the calculation, but it's still going to be an average. OEE is calculated using historical data from previous year. So if there is a change in production mix, it's not going to provide good results. So let's say you for 2020 you produce products A, B, and C. So you calculate your OEE using that production. So for next year, 2021, if you produce products X and Z, your OEE, it's not going to provide good results because your production is completely different from the previous year, right? Your production mix is going to be very different. It's easy to calculate, as you saw, but it means as well that it's easy to manipulate. Because there are goals associated with OEE, it's not uncommon to manipulate hectare times in order to provide a better OEE. So what is operation effectiveness? It is a deployment of a machine learning module in order to predict the efficiency of the operation. So the first thing you need to do, of course, is gather historical data. You need to plot and analyze. You need to decide what is going to be the machine learning algorithm that you're going to deploy. So it could be a regression, it could be a KNN, it could be a Handel Forest. And you need to decide which one you're looking at the scores. You build and train that machine learning module, and then you deploy it. After that, you can use the deploy module to predict required parameters such as the process time. So using the same example, we could predict what's going to be the process time, the available time, and the rework time. Of course, it's a prediction, so it's not going to be 100% accurate, but it provides a better, you have a higher chance of being close to the reality than using an average. So in this example here, you also are close to the 22 hours lead time, even though the numbers, the predicted numbers here are not exactly the same as the actuals, okay? Why it's a good method? Why it's a better method, let's say? First, it uses advanced statistical learning techniques, so it's possible to predict any parameter you want. So we are talking here to predict process time, rework time, and unavailable time. Those methods take into account historical data, same as OEE, but they can also use several other operation data points or features or attributes in order to better predict. Tailored to each manufacturing unit, so it's important for the deployment and the training of the module, the machine learning module, to happen at every manufacturing unit. So after that is done, predicting new values is very fast. And because it's easy and fast, you can pretty much integrate that with ERPs, APS, CPQs, any other manufacturing system, even Excel files if you want to, for automated predictions. Retraining is also pretty simple. So it's a push of a button. I can demonstrate that. And to me, that's the most important point. Efficiencies are calculated or predicted at the operation level, meaning that it provides a much better value for the quotation and planning processes. One example, this is an historical data, right? So you have here the actual process time, actual rework time, and actual unavailable time. You have several attributes. Every line here is one operation. So you have the order number and the operation code in this case. And you can use those categorical features. You can use those continuous features too. And of course, you're going to use the continuous targets in order to train your machine learning module and to predict then the process rework and unavailable time. In this example, the ensemble of Handel tree for regression is the module that provided the best scores. The challenge, of course, is having that historical data set. But in this example, we are using one data set that contains 3,000 operation, which is a pretty good data set. Predicted efficiency will be specific per operation using the formula below. So we predict those times, and then the efficiency is just the planar time divided by the sum of predictions. So it's pretty simple to calculate as well. Jumping into the demo here. So what you see right now is an APS, and this APS, every line here is one resource, one work center. Every colorful box is one operation. So let me sequence the future here. Okay, so this red dotted line here is the current date and time. So everything before that is in the past, and everything after that is in the future. So if I double click this operation, for example, and I click on operation actuals, you're gonna have information because this operation already happened. But if you double click this operation here, and it comes to operation actual, is gonna be 0 because this operation hasn't occurred yet. So And then all of those operations in the past here, they are the ones that were utilized to train the machine learning module. And that deploy module were used to predict the times of those operations. So if you double click this here, if I come to operation predictions, you're going to see the process time, the rework time, and the available time. They are the predictions. Right now, what you're seeing here, it's using the standard OEE. So the number that you see in every operation, which is a 1, meaning 100, is 100% efficiency at the operation level. That means we have an efficiency at the resource level. So you see that is a 65 efficiency no matter where we are, because we are that 65 efficiency is at the work center level. You see a 68 efficiency here for the SP21 resource. You're going to have for A10 resource 73 and so on. Okay, so this is the schedule that were provided by a standard OEE application. So what we're going to do, we're going to now first remove that OEE, right? So we're going to come back. The resource level will be at 100% efficiency now. Okay. So now if you see the lead time of the operation has been updated to reflect that. So if I come back here, you see the lead time before and after, removing that efficiency. So all resources now apply 100% efficiency. So I have more time to do more stuff. And also the operation at the moment is using 100% efficiency as well. So let's now apply the predictions. There is a tool here called Apply Prediction, where if I click, that number is updated. And you see that I have one number per operation. And that means that this operation here is 101% efficiency. We run at around 101% efficiency. This one, 88% efficiency. This one, 71, and so on and so forth. Now, if I repair my schedule, you see that the operations got corrected to reflect that new efficiency. Why this is a better process? It is a better process because now I'm more sure about the efficiency. I have, again, a higher chance to be correct on those numbers here because I'm using a machine learning module that provided a very good accuracy score. And so, for example, that's 27% efficiency. Previously, if you look here, that's how they were scheduled, right? Look at the lead time of each one of them. But after the prediction is deployed, I have a much longer lead time for them. That means that my shop floor can prepare to improve this number because they know my efficiency is low. I have a bad history of that type of product, right? So if I double click here and I come to attributes, the combination of those categorical and numerical attributes here, they provide, my history tells me that they run really, really badly in the shop floor. So this is it. I think it gives you a quick explanation of what operation effectiveness is. Just one last point here. If you want to retrain the module, there is a button here called Train Prediction Module. So I'm going to click it. I'm not going to wait because it's going to take some time. But if I click it, it starts to retrain the module using the new historical data that might be included here. Okay, after it's completed, then I have a new module, a new training module. So that's it. I hope you enjoyed. If you have any questions, any suggestions, feel free to drop us an email. All right, take care.